Yeah, hi all. In the last session, we have discussed about array list of list interface. In this session, we are going to discuss about linked list. So in the last session, array list, there are some limitations in array list. The disadvantage in array list is if we use the array list for frequent operations or manipulation, insert, delete, or update, then we require a lot of shiftings, so the performance will be low. So to overcome that problem, we can use the linked list. The linked list is a implementation class of list interface. As I shown you hierarchy previously, the list has implementation classes such as array list, linked list, vector. So the linked list is built using the data structure that is doubly linked list. So the underlying data structure of the linked list is doubly linked list. So internally it will follow the double linked list data structure. And as usually all list implementation classes allows the duplicate objects. So the linked list also allows the duplicate objects. An insertion order is preserved. Whatever the order we add the object, in the same order it will insert it. And heterogeneous objects and null insertion is possible. So the linked list have a specific methods. Whatever the list interface have a methods, all methods are by default available in linked list. Apart from that, it will have some methods. Those are add first. So what you to do, if you want to add the object very first, then we can use this method. And then add last. If you want to add this object in end of all objects, then we can use this method add last object, add last method. And then remove first, remove last. So it's a similar. And get first and get last. If you want to retrieve the first object, yes, we can get it. If you want to retrieve the last object, we can get it using get first and get last methods. So how it will be how it will be better for insertion and deletion, that we'll see. So in linked list, when we create an object, how it will create an object? So suppose if this is an object, if this is an object, see here I have an object, that is the object is just assume it's Srini is an object. It is an object. So this object will have a links, two links, is a front side and back side. It will have two links. So when I create an other object, when I create an another object, then this object also will have two links, same as this object. This also will have two links. So front side and one is in back side. So it is an other object. So the other object is student. Now what happen when I add this object? When I add this object, then immediately it will create a link from here to here. It will create one link. It is doubly linked list. So by using add first method, if I add one more object, that is employee object, if I add employee object here, then what happened? So here also every object will have link. It is doubly linked list. The underlying data structure, it follows the underlying data structure is doubly linked list. So here it will create one more object, that is employee object. Then what happen? It will create the link with this object. It will create the link with this object. So if you add an object by using last method, by using add last method, then it will create an object here and then it will link it. How it will be helpful in case if you add the object in between these. So if I add one more object, this is in between these two objects, between Srini and student, then here I am creating an one more object. So this is so every object will have two links. So it will be this object is data object. Then what will happen here? Then immediately this link, it just remove this link. It just remove this link, and then it will create a link between these two objects, and then the link between these objects. It will create link like this. So do we require shiftings? No shifts, because it is following doubly linked list. So both sides, the object both sides have a possibility to link the objects each other, so that just it will recreate the link. Previously the link was between Srini and student object. Now the link is between Srini and data and student. Here no more shiftings. So it will not take much time for insertion, because just it will remove. Suppose if I add here, just it will remove the link between these two and will create the link between other objects, among other objects. Among these three, it will create the link. So that will not impact other objects. So if I create one more object here, that will impact only these three objects, employee object and the new object and Srini object. But these objects, it will not impact on data objects and student object. So it will not take much time to create a link. But in case if it is the array list, then that is based on the index. So if I add an object in the first index, and then whatever the value is in the first index has to shift into second index, the second index value has to shift into third index, the third index value has to shift into fourth index, and so on. If there are 1 lakh records, then 99,999 times it has to shift it. So it will take much time. So to overcome that problem, we'll use this linked list. Just it will change the links between the objects, which doesn't impact much on other objects. So it will give a better performance. Even if it is the delete, suppose if you are deleting some object, the middle object, if it is the array list, if you delete the second object, then whatever object is in third index has to shift into second index, fourth index has to shift into third index, fifth index has to shift into fourth index. So it has to happen. It may take much time. If it is in linked list, then what happened? Just simply, now I want to remove this object. I want to remove this object. If I remove this object, this the data object. Yes, I have removed the data object. If I remove this data object, then what happened here is just the link. It will create the link between these two objects. These two objects will get linked. So it doesn't impact this object, so that it will give the better performance. Why it give the better performance? Because the underlying data structure is double linked list. Each object will have a links of both sides. So if you add any object in middle of the objects, among the objects, then it will just replace the links, so that it doesn't impact much on other objects, so that it will give a better performance. So I hope you understand. If our frequent operation is search, then we'll go for array list, because that is based on index. If our frequent operation is search, we should not go to linked list, because if you go linked list, here there will be no index. It is not based on index. There will be no index at all. So if it is if you are searching for student object, then you have to start searching from first object. You have to search here. So it is employee, it's not. Then you have to search here, and then you have to search here. Then you can find out the student. Because there is no index here, you have to search each and every object, whether this object is our object or not. It means that whatever the object you are searching, whether the searched object is it or not, if you want to find, then you have to check each and every object in the linked list. If it is the array list, it will have a index. So if you give the index number, directly it will go and pick the object based on the index. So if our frequent operation is search, then we'll go for array list. If our frequent operation is insert or delete or update, then we'll go for the linked list class. These both classes are implementation classes of list interface. So how will you use this linked list? See here. This is an object I have created. So as you already know how you have to create an object for this linked list. So linked list L new linked list. New linked list. So this is the way of creating an object. So we have created an linked list object. This is linked list object. This is the object reference. So now this is a object, a collection object. Now I can add multiple objects to this object. So how I can add? Using add method. I have a add method. So that is L dot add Srini, L dot add 30, L dot add null, again L dot add Srini. Because here see, if you observe, it will allow the duplicate values. Here Srini object as added, and again Srini object as added. And also it will allow heterogeneous, because it's a string, it's a numeric value, it's a null value. So it will allow heterogeneous objects. So let us run this program. With a right click, run as Java application. Now see, if you see here, this object has Srini, 30, null, and again Srini. It has 4 objects. Now if you want to add any objects, so we can add using the set method. See here, I am adding one more object using set method, that is software 30 null. So if you use set method L dot set, what happened here? So the object Srini is replaced with software. So the 0th position in the 0th index value is replaced with software. So in case if any object has to replaced with other object, then what the method we have to use? That is set method. Now the set method already I have used and replaced with software. Now I want to replace with Virat. So now see, the software is replaced with Virat. Now I want to remove the last object. So here, how many objects are here? Virat, 30, null, and Srini. Now I want to remove this object, this last object. If I want to remove, then I have a method that is remove last. From where? From linked list L. So L dot remove. If I use L dot remove, then it will remove the last object, that is Srini. Run as Java application. You see here, Virat 30 null. The Srini object is removed from here. Then if you want to add anything in the first place, then add first, add last. So using those methods, you can add something. So I want to add something that is wants to add something string in first position. So this is add first. So before this Virat, it will add something. See here, something, and then Virat 30 and 9. So these all of the methods are available in linked list class. These all the methods are available in this linked list class. These all are linked list class methods. The same methods are available in array list also. So this is an array list. So add method. So here also you can add the same values it will allow. Here also you have a remove. What are the extra methods are available in this linked list is add first, add last, remove first and remove last. These methods are not available in array list. In the array list it will have a add and remove, but we cannot add. In case if you want to add first or last based on the index, we can add it. We can give the index. So if you give the specific index, in specific index we can add the values. But here we have in the linked list we have methods. Those are add first, add last, remove first, remove last methods. So these two classes, array list and linked list, both classes are implementation classes of list. Then what's the difference between these two is this array list follows it's the underlying data structure of array list is growable array or resizable array, whereas for linked list it's a doubly linked list. The underlying data structure is doubly linked list. And the methods, there are some methods. So the linked list has add first, add last, and remove first, remove last methods. Those are not available in array list. The remaining all are similar. Then the question is, when we have to use array list, when we have to use linked list, because whatever we can do using array list can do using linked list also. Whatever we can do in linked list can do using array list also. Then when we have to use the array list, when we have to use linked list, when our frequent operation is search, then we will go for the array list. If our frequent operation is manipulation, then we will go for the linked list. The difference between the array list and linked list. And then the next class is vector. The next class is the vector class. The vector is also implementation class of list. So array list, linked list, vector, all are implementation classes of list. So list, whatever the capabilities of list, the same capabilities applicable for array list, linked list and vector. Some variations, there are some variations. The variations are, for vector class, the underlying data structure of vector class is also a resizable array or growable array. For array list also, the underlying data structure, what is the underlying data structure for array list? The underlying data structure of array list is resizable array or growable array. Then for vector class also same. It is also the underlying data structure is growable array or resizable array. And insertion order is preserved. Yes, the same for array list also. Duplicate objects are allowed. Yes, it's the same for array list. Heterogeneous objects are allowed. Yes, it's similar to array list. Then the best choice if the frequent operation is retrieval. Yes, array list also the best choice when it is frequent operation is retrieval. Then the only difference is the difference between this array list and vector is the vector all methods are synchronized methods. You know what is the synchronization? If the method is synchronized, it will allow only one object. It will allow only one thread to execute it. It doesn't allow multiple threads. So it's a thread safe. So only one object can get execute the synchronized method. Whereas array list, no method is a synchronized method. So these are the differences between this vector and array list. The major difference is it's a synchronized methods. Vector class have all synchronized methods. The vector class also have a methods. Those are add method. So whatever the methods, the vector class. So vector class also has a methods add and remove. So the same methods are available for array list also, because these all are list implementation classes. Whatever the list methods, the list method, add method is the list method, remove is the list method, list interface method. So whatever the methods are available in list interface, all those methods are available for all these implementation classes such as array list, linked list and vector. So methods are same, the underlying data structure is the same, everything is same. The only difference is all the methods are synchronized methods in vector. Here no method is synchronized method. So since it is the synchronized methods, so it's a thread safe. Vector object is the thread safe. It means that only one thread can execute at a time, whereas array list methods are not thread safe. Then if it is a thread safe, obviously the performance will be low because it's a synchronized, it will allow only one object at a time. So if there are 100 objects, so the first object has to execute and then it has to release the lock and then second object and then third object and then fourth object. So it has to execute 100 objects. It may take much time because this is a thread safe, so the performance will be low. But here, no method is, it is not a synchronized method. All 100 objects can execute the same method at a time, so the performance will be high. The performance will be high. So the vector class is a legacy. So legacy is nothing but it's a very old class. It's a new. It's given in 1.2 version. It was in 1.0 version. So when will you go for the vector? If we specifically require the thread safe, then only we will go for vector. Otherwise, we will go for the array list because it will give the better performance. Then programmatically it's the same. Whatever the array list can do, the same vector also can do. So vector is a class. How will create a vector object? So here vector is a class. So vector is equal to new. This is a way of creating an object, and then the initial capacity of the vector, what will be the initial capacity of the vector is, you can see here the initial capacity of the vector. The initial capacity of the vector will be 10. Initial capacity, V dot capacity, the initial capacity will be 10. Once it reached, so because it is also index based, once it reached the 10 objects, then immediately it will double the capacity. Is 10, then the next capacity will be 20. Once it reaches the 20 objects, then again it will double. The current capacity is 20, now it will double 40. So like that it will doubles every time. Once it reaches the maximum size, then the capacity will double. We get double. This is about this vector. And then the vector has a class, the child class, that is stack. Vector has a child class, that is a stack. So the stack has a methods. The stack has a methods. Those are push method. Push method. Why we use this push method? For inserting an object to the stack. So how it will be, the stack is, the stack will create so previously array list, those are based on index. It will create first index, second index and third index, but here it will create, the stack will create like this. This is a stack. The stack object will create like this. So here in the stack, here we have a methods. Those are push method. What if do the push method? The push method for inserting an object to the stack. And then pop method, it remove and returns the top of the stack. So if there are 100 objects, if you use pop, then it will take the topmost object and will return, and it will remove from the stack. And peek, what it do, this peek, it returns the top of the stack without removal from the object list, from the stack. And then we have a search method, the search method to get the specific object. And then empty method, the empty is, it returns true if the stack is empty, otherwise it will return the false. So these are all the methods are available in this stack. So the example for stack is, so this is a way of creating an object, that is stack s equal new stack. Anyway, we will not use much in real time, so but you should have a knowledge of what the stack and what the methods are available in this stack. So the stack has a methods, those are push. So when we use this push, so let's see up to here. I will show you the purpose of each method. So the push method, when I use this push method, what happens here, it will create objects, it will add into the stack. Now the stack has A, B, C, A, B, C. Now pop method, what you to do the pop method, if you use this pop method, so S is the object. What object? Stack object. S dot pop, S dot pop. What you to do the pop method? Pop method, it removes and return the top of the stack. It removes and return the top of the stack. Now see what will be the, what it will return the C. Now S is S dot pop. It return C. It return C. So what is the top? What is the top? So the top is C. How it will create an object, as I shown you previously, that is so. Okay. So now the A value will add here A, and here it will be B, and here it will be C. So like this it will add from top, from bottom to top, it will create an object. Now here we have three objects A, B, C. So what's the topmost object here? C is the topmost object. When you use C, then it will return the topmost object. When you use pop method, it will return the topmost object. The topmost object of the stack is C, so that it will return object C. And then is printing the stack, and then printing stack. What it to do this pop method, it fetch the topmost object and remove this from the stack, and then it will remove from this stack. Now it will remove from the stack. Now if you see, it will give only two objects, those are A and B. See here A and B. This C object is removed because of we are using this pop method. This pop method. Then the next is peek method. What's the purpose of this peek method? It returns the top of the stack without removal of the object, without removing the object. So here what is the topmost object? B is the topmost object, but it doesn't remove this object. Without removing this object, it will fetch it, peek method. So let us see here. It's a peek method. So after peek we are printing. So what it will do, it will take the next topmost object, that is the value B, and it will doesn't return, it doesn't remove from the stack. So it B is returned, because here what is the topmost object here? The topmost object is B. It has taken, but it did not remove from the stack. So still these two objects are available in this stack. We are printing the stack. And then search. What it will do the search? So the search object, it will return the position of the stack. So it will calculate from top. So in the top B first and second, the second position. It will return the position of the second. So empty, it will check whether this stack is empty or not. So it is s dot empty. S is the stack object. S dot empty. If it is empty, it will return true. If it is not empty, it will return false. Now it is not empty, so it will return false. So it has written the false. Okay, so we have discussed about this list and list implementation classes. So these all classes we have discussed: the list and array list class, linked list class, vector and stack. So we have discussed about this list and list implementation classes. In tomorrow's session we will discuss about set and set implementation classes. So until then, take care, bye bye, good night.